Hi, in this video I'm going to solve three problems involving the force of gravity. We're going to use free body diagrams and Newton's second law in order to figure out different things about different situations. So let's look at our first problem. An 8.2 kilogram bowling ball is dropped from a tall building. Halfway down, find the acceleration of the ball using Newton's second law. Air drag is negligible. So we're going to start, as always, with a free body diagram. It's a bowling ball, and the only force acting on it is going to be gravity, mg. Air drag is negligible, so there's nothing else. Our acceleration is going to be in the downward direction, and also our velocity is in the downward direction. Newton's second law says the sum of the forces, or mass times acceleration, is equal to the sum of the forces. So the mass of the ball times the acceleration is equal to, well, the only force here is mg, so it's going to be equal to mg. And we need to find the acceleration. We divide both sides by m. And we're left with acceleration is equal to g. And on Earth, g is going to be equal to 9.81 meters per second squared. So this is an interesting result. Our acceleration doesn't depend on our mass at all. It only depends on g, our acceleration due to gravity. And this is not normal. Gravity is kind of a weird force in that it causes everything to accelerate at the same rate, no matter what the mass is. But we can't really talk about why that happens until we get to general relativity to give us the true cause. But we're not going to worry about that right now. Question number 3. A 0.49 kilogram ball is dropped from a tall building. Halfway down, the drag force is 3.6 newtons. Find the acceleration of the ball. So I'm going to draw my ball. Our downward force is the force of gravity, mg. And our upward force is the drag force, force of drag. We are given the mass is equal to 0.49 kilograms. And so we can find the force of gravity. The force of gravity is equal to mg, which is equal to 0.49 times 9.8. 4.8 newtons. So I'm going to add that to my diagram just so we have it. 4.8 newtons. We also know that the drag force is 3.6 newtons. 3.6 newtons. So I'm adding that to my diagram as well. Let's just move this out of the way a little bit more. Since the gravitational force is greater than drag, we are going to have a downward acceleration. And we're also still moving down, so there's going to be a downward velocity. Now let's set up Newton's second law. Mass times acceleration is equal to the sum of the forces. Ma is equal to, well, our downward force is mg. That's going to be our positive force because our acceleration is down. So ma is equal to mg. Drag is in the negative direction, minus force of drag. If we want to solve for acceleration, all we have to do is divide both sides by a. Whoops. We divide both sides by m, actually. M cancels on one side, does not cancel on the other side. We end up with acceleration is equal to mg minus our drag force divided by m. And we get mg we already solved for, it's 4.8 newtons, minus 3.6 newtons, divided by our mass, 0.49. It's 0.49 kilograms. And you might notice that up top we just have our net force. It's our vector sum of our forces divided by mass. Acceleration is force over mass. Up top, we're going to get 1.2 newtons divided by 0.49 kilograms. Gives us a net acceleration of 2.4 meters per second squared. A equals 2.4 meters per second squared. Okay, there's problem 2. Our last problem is right here. A fruit is dropped from a building. Using video analysis, you measure the acceleration to be 6.7 meters per second, a third of the way down. If the drag force is 2.2 newtons at this point, find the mass of the fruit. So again, we're going to do a free body diagram. Force of gravity pulls down, and the drag force is going to be pulling up. We know the drag force is 2.2 newtons, and that's about it. So let's set up Newton's second law. Mass times acceleration is equal to the sum of the forces. And mass times acceleration is equal to our downward force is mg. Our upward force is the force due to drag. We can then rearrange this. We're solving for m, and we actually have two terms with m in them. So in order to get m on its own, we need to group them together. Let's subtract off mg from both sides, minus mg. We end up with ma minus mg is equal to negative drag force. We can then factor out an m on the left side. We end up with m times a minus g is equal to negative drag force. If we divide both sides by a minus g cancels on the left side, we are going to end up with, and I'm going to move over to here, mass is equal to negative drag force minus a, or divided by a minus g. And we've solved it. We just need to plug in our givens. We know Fd is equal to 2.2 newtons. We know g is going to be 9.81 meters per second squared. And we know a is equal to, that's in the problem, as 6.7 meters per second squared. So when we plug in, we get m is equal to negative 2.2 newtons divided by 6.7 meters per second squared minus 9.81 meters per second squared. We end up with 2.2 divided by 6.7 minus 9.81, 0.71 kilograms to 2 sig figs. That question was a little bit more complicated only because we needed to factor, but if we write out the Newton's second law equation, then it ends up working out for us either way. Anyway, hope you find these problems useful. Bye.